Assalamu alaikum, welcome again. Here we have another multiple domain problems. So we need to find also overall heat transfer coefficient. But let me see here. Do we have to? Okay, we have a composite wall, then another layer, and 5 cm. Okay, so we have three domains. Okay, and actually I don't draw it with exact dimensions, but we have three domains. Okay, so the first one is 2.5 centimeters, the other one 3.2 millimeter, and the third one 5 centimeter. Okay, and the k values, k1 is given. Okay, it's not given, so we will find them from the tables. Okay, and the wall is subjected to an overall temperature difference. Okay, but let's put K1, K2, K3. Overall temperature difference of, so you have T1 here and T3 here. So delta T is 560 degrees of Celsius. What is the heat flow per unit area through the composite structure? Okay, so you have Q per A is just U times delta T. And U is being calculated by L1 over K1 plus L2 over K2, L3 over K3, but you also take power of -1, then temperature difference. Okay, if we get thermal conductivity of the materials from the table, from appendix of the book, you will find the values like this. So let's start putting the values. So we should use meters because here it's given as per unit meter. So L1 is just 0.025 meter over K1, which is 369. Okay, it's a conductive copper. Okay, then we have insulation layers. So meter degrees of Celsius plus L2 is just in millimeters, so 0.0032 meter over 0.149. So it's an insulating layer. So here you have 0.005 meter for the third layer, which is fiberglass with 0.038. So fiberglass is a porous material, I can say, is a porous material with having a lot of empty places with air. So it will have a high insulating property. Watt per meter degrees of Celsius. So you have 560 degrees of Celsius. Okay, so actually meter will come to up, and also degrees of, okay, you have -1 here, so don't forget that one. So at the end you will have meter square up. Okay, so we have the same idea here. So let me show meter square times degrees of Celsius over watt. But when you get -1 of that unit, that will give you watt per meter square degrees of Celsius. So that degrees of Celsius actually will cancel this term. So you have watt per meter square. Okay, so let us see what is the final result. Over 369 plus 0.0032 over conductivity plus the length over conductivity. Then close the parentheses, but don't just forget to get power -1 multiplied by the temperature difference. So you get 418 watt per meter square. Okay, please check your units for each parameter. Don't forget to consider your unit, because as you see, centimeter, millimeter, you have watt per meter, Celsius, so a lot of things. So you should consider the units, and at the end we have the final result. Thank you for watching, and see you at the next video.